now I will continue with that. I will share my screen. Able to see my screen?
Yes, sir.
Yeah. Okay. So actually, I will continue same STL. We'll see if there is a time we will start with the programs also. First, let me finish this some other theory part regarding this STL. See, yesterday we had a discussion about STL. Full form of STL is nothing but standard template library. Why we go with this STL means I told you some reasons. So here STL is nothing but suppose I have taken one example, that is if you take array. In array we cannot increase, decrease dynamically. That is the main. If you take an array, it's having some advantages and it's having some drawbacks. See, one of the main drawback is we cannot increase or decrease the size of the array. It's having many other drawbacks. Arrays. See, once we declare an array with some size, that is, if it is 100, if you use only 20, wastage of memory. If you use 100, if you want to make it like 150, it is not possible. So that's why, and already I told you majorly what we do with the data structures. Already we discussed what is the importance of data structures. Whenever we want to maintain some data, in data, definitely we need data structures. Without data structures, it is not possible. So, and most common used operations are within data structures. They are insertion, deletion. They are common in data structures. Mainly, what we face within data structures while doing this insertion and deletion operations, mainly is problem is space. See, space means, so whenever you are in a position to allocate more memory than existing, and whenever you are in a position to remove some space of memory after using, in that cases you can handle. That is nothing but the solution for the space problems in space. So that can be overridden by using STL. See, and one more is why we go with this STL part is, as a programmer, now you people are writing code for all different types of data structures. We need to write each and everything. You need to create a node by using some structures, and then you need to insert some data, and by using pointers, it is navigating to some other node. So like that, we write some code in number of lines, minimum 50 or 60. It depends upon the programmer. But especially in C++, I told you all these points, just I am repeating. In C++, it's having one built-in library. It's having some built-in library for writing all these programs. We can call it as like these are nothing but a collection of classes. That is nothing but it is STL, standard template library. So finally, I concluded that STL is nothing but it is a collection of header files. Otherwise, you can call it as STL is nothing but it is collection of built-in classes. Collection of built-in classes. We discussed all these things. So now, components of HTML. Component. This is very, very important, students. You must know this. Components of HTML. See, these components, it varies from author to author, but most of the authors, they're telling that components of STL are three. Three are the components. Visual, it is having three components. Visual, it is having three components. First component is algorithms. Second component is containers. Third component is, instead of this, better, I will write here, this is iterator. Iterators. Iterators. This is containers. So these are the three components, students. One is algorithms, next is iterators, and next one is containers. So first one is algorithms. So algorithm means, first let me tell you the basic concept, basic objective of each and everything. Then when we start discussing about all this, then you come to know. Algorithms are, we can call it as built-in functions. We can call it as algorithms are nothing but it is built-in functions. Built-in functions. Algorithms. See, theoretically it is having some other definitions about these algorithms, but in a single line I can say, so algorithms are nothing but it is algorithms for built-in functions. Algorithms for built-in functions. Whereas containers, next one is containers. Algorithm, next one is container. What is container? Built-in classes. Built-in classes. So containers are the built-in classes. Built-in classes. Now, and one more thing is containers mainly used to maintain data. Maintain data. We can call it as like it contains data. Contains data. Now, what about iterators? Iterators. Iterator is nothing but it is mediator. Is mediator between algorithms and containers. Algorithms and containers. This is very, very important. It is a mediator between algorithms and containers. That means see here majorly see just I will write down here. This is algorithm. This is container. Just I will write down. These are nothing but algorithms. Algorithms. This is nothing but it is container. This is nothing but it is container. And one more is this is iterator. This is called iterator. This is called iterator. See, container is very, very important. Algorithm is important. Iterator is also important. But by using algorithms, you cannot directly communicate with container. How it is possible means, first it must go with iterator. With iterator only you can invoke containers. That is very, very important. With iterators only you can invoke the container. Algorithm, iterator, container. With algorithm, so how algorithm is actually main thing is